Please like the video and subscribe my channel to get updates. Also press bell icon to receive notifications of new uploads. Namaskar friends. In engineering graphics we come across many times a lot of geometrical constructions which sometimes may create problems, and your drawing may be stopped just because we don't know how to draw those geometrical constructions. So in today's video we will be talking about basic geometrical construction which are used in engineering graphics. So let us start. First we will find out how to bisect a straight line. Say you are given a straight line equal to say 7 centimeter or any length. You can take any length, right? So this is a 7 centimeter line, or any length of the line is given to you, and you have to bisect this line into two equal parts. So what you can do, take A as center and radius equal to more than half of the line, draw an arc this side, draw an arc this side, taking A as center. Take B as center now with the same radius, cut these two arcs, draw the perpendicular bisector of the line. So this P point is the midpoint of line AB. Similarly, you can divide a straight line into different number of equal divisions. Say any length of the line is given to you, and you have to divide this line into 6 or 7 or any number of equal parts. What you have to do, just draw an angle here. This angle must be an acute angle, means less than 90 degree. Any angle you can draw, so need not to measure also, just draw with the scale an angle like this. Then starting from A, take any arbitrary radius on divider or compass, any radius which you like, and start from here. Take A as center, cut one mark here which may be given the name as 1 dash. Then take 1 dash as center with the same radius, cut another one, 2 dash it will be. Then 2 dash center, 3 dash will be obtained. Then 4 dash, 5 dash, 6 dash, 7 dash, or whatever the number of divisions required. Then join this last point with the point B, and using mini drafter or set squares, draw parallel lines parallel to 7 dash B, starting from here. From all these divisions, put here like this on 6 and draw a parallel line parallel to this line 7 dash B. Then put here mini drafter and draw the another line parallel to the previous one. Similar method. When these lines cut this actual line at some points, these points are the equal divisions of this particular line. So this will be 1, 2, 3, 4, 5, 6 and 7. So you have divided this straight line into 7 equal number of divisions. Now we can divide and bisect angles also in equal number of divisions, or we can divide into two equal parts. So say for example you are having an angle like this, and you have to divide this theta angle into two parts, or we have to bisect this angle into two parts. So take O as center, and with any arbitrary radius cut an arc here. This radius is not fixed, you can take from your own. This arc will cut the two emerging lines from O at say 1 and 2. Now with the same radius, take 1 as center, draw an arc this side, take 2 as center, cut the previous arc. When you join this O point with this intersection point, say this point is point M, this is the angle bisector, that is the theta has been divided into two equal divisions. Similarly, if you wish to divide any angle, say this is an angle, and you wish to divide it into 7, 8 or 9 equal divisions, whatever the number of divisions are. So what you need to do, Just take OS center and cut an arc here of any radius. Then take divider and whatever the number of divisions are there, say for example, if I wish to divide this into 7 equal divisions, so arbitrarily choose on the divider a radius which you feel that it will be the 7th division, and start from here. Put the divider here, first, second, third, fourth, fifth, sixth and 7th. You can see here the last point is just finishing just below the final point. It means that your radius is not proper, so you have to increase the radius in the divider and again do the trial and error method. It may be possible it will finish above the final point. So this point is A and this is B, so it is just after the point B. It means the radius is increased a little bit more, so you have to decrease that radius. After 4 or 5 trials, you will see that when you will do the trial and error method, you will finish at the point B itself. It means that is the proper division. Mark on this arc with that particular division, the final division, and then give the numbering and so on. So in this manner you can divide this angle into equal number of divisions. Then we come, there is a circle which has to be divided into 8 or 10 equal parts. So this is the circle, say for example, and this is another circle. This circle you want to divide into 8 divisions. So what you do, with the mini drafter you can draw a horizontal line passing from the center of the circle, and one vertical line can be drawn like this. This will divide this circle into 4 equal divisions. Now using the bisection method, you can divide this angle into 2 parts and extend. Similarly, you can divide this angle, bisect this angle and extend. Alternatively, you can draw 45-degree angles both the sides. So this will divide the circle into 8 equal divisions. For 12 divisions, first divide this circle into 4 equal parts. Then there is a method what you can do, say this is the center and this is A point. So take AO as radius, that is the radius of the circle, and take, say, once take A center, radius equal to AO, and center is A, and cut an arc this side. Similarly, take CA center with the same radius, cut this side also. So this is first, second. So this circle has been divided into 3 equal divisions now. You can extend these lines to divide the other half of the quadrant into 3 parts. Similarly, you can do from here, cut an arc here with the radius AO, taking this as center, then take this as center and cut another arc so as to divide this again into 3 parts, and you can extend these lines, or alternatively you can do that method in these quadrants also. In such manner you can divide any circle into equal number of divisions. Now we will be understanding how to draw simple figures like triangle, square, rectangle or a parallelogram in the engineering graphics. So if 3 sides of a triangle are given, you can easily draw, we have already seen. Now to draw a square, say you have to draw a square of 30 centimeter side, 30 mm side. So what you need to do, just draw a line equal to 30 mm. Say this is line AB. Now there may be 2-3 methods. You can draw 2 perpendiculars on this line and cut 30 millimeter both the sides so as to get the square. Or you are having mini drafter, you can draw a parallel line parallel to this AB here at a distance of 30 millimeter and then join with the vertical face so that you are getting the square. Similarly, rectangle can be drawn. Say the rectangle's dimensions are 60 and 40. This line is 60, say for example, and the vertical side is 40 mm. So what you need to do, again you have to draw this Draw the perpendicular lines and cut 40 mm both the sides so as to get the rectangle. Similarly, to draw the parallelogram, what you need to do, you need to have the bigger line. You should have, say this is 60 mm, and the included angle of the parallelogram may be provided. So draw that angle here, whatever the angle of the parallelogram is given, draw this angle this side also, and then cut the smaller side on both the lines here, so that that parallelogram is drawn. One more figure is there, that is called rhombus, and that rhombus has property that the diagonals of the rhombus are perpendicular to each other but unequal, and all the four sides are equal, just like square. But the difference between rhombus and square is that the rhombus shape is generally like this. So these diagonals are unequal but the sides are equal to each other, while in case of square all the sides are equal and the diagonals are also equal in this particular diagram in 90 degree to each other. Here the diagonals are also 90 degree to each other. So diagonals are 90 degree, here also it is 90 degree, all the sides are equal, all the sides are equal. The only difference is unequal diagonals are there in case of rhombus. So to draw a rhombus, you should have the length of the diagonals, so you can draw the bigger diagonals, then a perpendicular bisector of this, cut the length of the smaller diagonals, and then join that. That will complete the rhombus also. So in this way you can draw the basic figures, basic geometrical construction while you are drawing any problem in the engineering graphics. Thank you very much.